Train A leaves the station going 30 meters per second east. If train B starts 900 meters east of the station and travels west at 20 meters per second, when and where do the trains meet? This problem might look intimidating, but with a little bit of physics trickery, we're going to knock it down really fast. But a great first step for solving any physics problem is to draw it. So let's do that. So here we've got the two trains. Train A is just starting over here, moving to the right. Train B is over here, moving left. And they've got a 900-meter gap to close between them. And we want to know when and where that's going to happen, where the two trains will collide into each other. In order to knock this problem down, I want you to think back to a moment from your childhood. So do you remember on family trips when you would sit in the back of the car as your parents were driving and you would just look backwards out the window? And it was really cool because if you were on an interstate or something where you've got cars going the other way on the other side of the road, then they would look like they went really fast, right? So if your car was going 60 miles an hour this way, then, and the cars this way were going 60 miles an hour in the opposite direction, it appeared to your eyes like this car was a rocket ship or something, like it was going 120 miles an hour, right? That's because from your point of view, you were in this car. If you're moving forward and they're moving backwards, then those two velocities add. If somebody who was just standing on the side of the road were watching, he would say that this car is only going 60. But since you're in a car that's going 60 the other way, you get a totally different answer, and it looks like the thing is just going crazy fast. We can apply that idea to this problem. So instead of looking at this as someone from the ground, let's look at it from the perspective, from the frame of reference of someone in train B, and see if that helps a little bit. So according to this guy, it looks like train A is coming toward him at 50 meters every second, right? If he's moving 20 to the left and this is moving 30 to the right, they're coming together 50 meters every second. So we can use that to our advantage. If every second these two get 50 meters closer together, because this one goes 30 to the right and that one goes 20 to the left, and they have to close a gap of 900 meters, then all we have to do is 900 divided by 50. They wanted to go 900 meters, and they were coming together 50 every second, so it would take the two trains 18 seconds to meet. And where exactly would they meet? Well, if they traveled for 18 seconds, then, and this one's going 30 meters every second, then this one traveled 540 meters, 30 times 18. And same for this cart. It would just be 20 times 18, which is 360. And what do you know? Those two distances add up to 800 or 900, and all is right in the world. A car accelerates from 0 meters per second from rest to 30 meters per second in 5.3 seconds. What was the acceleration, and how far did the car go during this time? Now this is a classic acceleration problem, so we're going to have to set up our 5 variables of awesomeness here, VI, VF, AT, delta X. And our goal is to fill out the entire chart, but some of the information was already given to us. So the information that we were already given in the problem has been highlighted, and those numbers have been thrown in the chart. The two things that we're digging for is the acceleration and how far it traveled, which is delta X. So over here to the right, I listed our 3 equations of awesomeness that we can use to try to figure out this missing information, the A and the delta X. Now our objective is to find one of the equations that has all the information that we know and also has one of the pieces of information that we're looking for. So the problem asks us to find acceleration first. If you look at the first equation over here, it has all 3 of the values that we also have, VF, VI, and T, and it only has one missing, which is A, so we should be able to solve for A by using that equation. So let me do that for you. When I plug those values in, I got an acceleration of 5.7 meters per second, and I throw that information into the table. Now all we need is delta X, so we find one of these formulas that has a delta X in it. You can actually use either one that you want, but for this case, I think I'm going to use this one. If I apply that equation, I end up with a delta X of 80 meters. Go ahead and pause the video to check that stuff. And while you're at it, here's how you could have done it using the average velocity method, which is quicker.